Today we are doing part 2 of lesson 11.3, the tangent line problems. Now in this part we finally add the correct term to what we've been doing, which is called the derivative. Right? So it is a formula of the slope of a graph, specifically at a point, and the symbol for that is this value right here, which we call f prime of x. And again, that stands for the limit as h goes to 0 of f of x plus h minus f of x all over h, provided this limit exists, right? We have one over where it could not exist if we had maybe an asymptote, or a couple different versions where the denominator was 0, numerator was a different number, so typically it was an asymptote. It was the most common mistake we ran into. Moving on. We've got find the derivative of 2x squared plus 5x. So this kind of goes back to the beginning problems, finding the slope of a line, just in general, finding the derivative. Now, again, this isn't the slope necessarily because we don't have the x value yet. I will put the answer up here in the end so that you can kind of look to see if you can notice the pattern of how these answers go. So f of x plus h right here, negative 2 times x plus h squared plus 5. Notice there's another x. You need to plug x plus h in for each x. If it appears more than once, you should have more than one. And now simplifying, again, as a reminder, this is x squared plus 2xh plus h squared. We had that as a memorization earlier on. This will be 5x plus 5h. Okay, and then the negative 2 will distribute. So minus 2x squared minus 4xh minus 2h squared. And then 5x plus 5h was still fine, and then we're going to subtract the original. Subtracting a negative 2x squared plus 5x gives us a plus 2x squared, so these cancel, and a minus 5x, so these cancel. So notice everything left over has an h, and then we'll divide by h. So taking the h's away, we get minus 4x minus 2h plus 5. And so then we're doing the limit of this, once we took the h's out, one of each, as h goes to 0. So any h's that didn't cancel, we no longer have h 0 over 0, right? This simplified, we've got minus 4x plus 5, and then that is our derivative. Now, this is the slope at each point on the line here. However, once we have a point on the line, we have an x value, then we could plug that x value in to find the actual slope. Now again, look for where could that minus 4x have come from here, and where could the plus 5 come from there. Next, x cubed plus 2x plus 1. Now again, x cubed was one we did before in terms of the x plus h cubed, so I'll re-say that one in a little bit, plus 2x plus h plus 1. So we've got to deal with this. X plus h times x plus h times x plus h is x cubed plus 3x squared h plus 3xh squared plus plus h cubed, not 3, just plus h cubed. So that's this. This is just going to be 2x plus 2h and then plus 1. And now we're going to subtract the original. Because this is a little bit longer, I sometimes subtract the original underneath. So minus x cubed, you're going to go right here. Minus 2x, we have an h, have an h, have an h. Minus 2x is going to go right here. And then have an h minus 1 going to go right here. You shouldn't ever end up with something without an h before we divide by h, right? Everything that doesn't have an h will go away, right? So those will cancel, and we've got 3x squared h plus 3xh squared plus h cubed plus 2h. And then we divide by h. So then I cancel out the 1's, and if we have 2, I'll cross out and put a 1, or just leave it. In this case, cross out the 3, put a squared, and cross out the 2h becomes plus 2. As a reminder, if we ended up with plus h over h over h is 1, right? If we don't see the coefficient, it's 1. And now we've got limit as h goes to 0 of 3x squared plus 3xh plus h squared plus 2. Both of these pieces go to 0 when we plug 0 in. 3 times x times 0 is 0. Plus 0 squared, 0. So we just have 3x squared plus 2, and that is our final answer for that one. If I am going a little quick through these slides, make sure you hit pause at the end to write down what you need to write down. Moving on, now finding the formula of a tangent line to a graph. Now again, so having done part 1, you've already seen finding the slope of a tangent line. That is what the derivative does, right? So that's why step 1 here is find the derivative, and then we're going to plug in the x value that they give us for that into the derivative to find the slope at the given point. Next, we'll have the point they gave us and our slope from step 1. With that information, given point slope, you can find the equation. So find the y-intercept of the slope through the given point and the found slope by using mx plus b. However, I have typically done the y minus y1 equals mx minus x1. And so then I can simplify a little quicker using that. That is point slope form. I may not necessarily do the y equals mx plus b method stated here, but when we're done, we're going to simplify into y equals mx plus b. Moving on, we've got 2x squared minus 4x is our function, and we're looking at the tangent line at the point -1/6 of this. So f of x plus h minus f of x all over h, right? Doing this a couple times. Here's our f of x plus h, x squared plus 2xh plus h. The minus 4 distributes here, and there we go. Times 2, we get 2x squared, 4xh, 2h squared. The minus 4x minus 4h comes down, and then we're subtracting the original, right? This was f of x plus h. Switch color for minus f of x again. So minus 2x squared minus negative 4x, which becomes minus 2x squared. This goes away. Has an h, doesn't have an h, so minus a negative 4x plus 4x, so that's gone. Has an h, right? All our leftover pieces should have an h. And now we're rewriting what's left over, 4xh plus 2h squared minus 4h all over h. The h goes away, 4x. H squared becomes h, minus 4h becomes minus 4, and so we're going to be 4x plus 2h minus 4 as the limit as h goes to 0, so 2h now disappears to get 4x minus 4. How does that come from here and here? And then we're plugging in x is minus 1. So if x is minus 1, right, we get negative 4 minus 4, which is minus 8 is our slope. And now, minus 8, negative 1, 6, we can do y is mx plus b, or y minus y1 equals mx minus x1. Again, in y equals mx plus b, just for refreshing your memory, we have an x value here, we have a y value here, we have an m value. The only thing left in y equals mx plus b would be b. If you plug these three in, you'd solve for b. This way, instead of solving for the piece and plugging it back in, we're just going to plug in the y value for the point, the x value for the point, and the slope. We'll still have y and x because they will be left over in our linear equation. Right? We'll have y equals mx plus b when we're finished. So plugging it in, y minus 6 equals negative 8. That was over here. X minus negative 1, which is plus 1. I'm going to multiply negative 8x times, and then negative 8 times 1. And then we're bringing the minus 6 over by adding 6 to both sides and then simplifying. Negative 8x minus 2 is what I've got, and there it is. Y equals minus 8x minus 2 is our final answer. Moving on, we've got f of x equals square root of x at 9, 3. Okay, as a reminder, square root of x is the same as x to the half. And so f of x plus h minus f of x right here. There's not a lot of simplifying going on there because we can't really simplify this. So we can't really simplify this without multiplying by conjugate. So here we go. This is a minus b, a plus b over a plus b. So we'll get a squared minus b squared here, which would be x plus h minus x. I didn't bring the parentheses because it's only x. If there was more pieces here, we would put a parentheses. And then the x's in the numerator are going to cancel so that we can have just h. And that will cancel right here, and then we'll be left over with that, right? And so once the h's cancel, we have limit as h goes to 0 of 1 over x plus h square root plus square root of x. Well, we plug in h is 0, and we get 1 over square root of x plus square root of x, which is 2 of them. And now we're plugging in 9 for our x value. Square root of 9 is 3, so 1 over 2 times 3 is 1/6. And there's our slope. And now we have the slope 1/6 and the point 9, 3. And so y minus 3 equals 1/6 x minus 9, 1/6 x minus 9/6, or I'll leave it like that until we finish the 3 and then we'll simplify. plus 3 to both sides, and then because we have 6, we turned it into 6. I got 18 6 minus 9 of them. This is going to be plus 9 6. 9 over 6 is 3 halves. So we get y is 1/6x plus 3 halves. Next, use a derivative to determine any points on the graph where the tangent line is horizontal. Now again, what this means is if the tangent line is horizontal, typically that happens at either like a maximum or a minimum, which would be considered typically a relative min or max, and those are called, in some classes they call them turning points or extrema, right? Because minimums and maximums are considered extrema. So f of x is x squared plus 5x plus 1, right? And what we're going to do is find the derivative of this, and then we're going to set it equal to 0, because if the derivative is 0, the change being 0 would be at a maximum or a minimum, right? The tangent line would be the slope. If the tangent line is horizontal, the slope would be 0, right? So again, that's what we're saying here, right? So f of x plus h is this, x plus h squared plus 5x plus h plus 1. Simplifying, x squared plus 2xh plus h squared plus 5x plus 5h plus 1. Then subtract f of x, the original. Getting 2xh plus h squared plus 5h is what we have left over. All over h. So 2x plus h plus 5, right? Just chop 1h in each piece term. And we get limit as h goes to 0 of 2x plus h plus 5. Well, this h is 0, so 2x plus 5. And then we set that equal to 0. So subtract 5 divided by 2, and x is negative 5 half would technically be our minimum for, minimum for this equation. That'd be the x value where our tangent line is horizontal. One more of these to wrap us up, and we have x cubed minus 3x squared plus 5. And so we're going to need to do the x plus h cubed minus 3x plus h squared plus 5. So quite a long problem. X cubed plus 3x squared h plus 3x h squared plus h cubed is just that. Minus 3 times x squared plus 2xh plus h squared, and we get minus 3x squared minus 6xh and minus 3h squared. And the plus 5 finally gets written way over here. And then subtract the original, because this took up almost the whole slide, left to right. We'll just write the minus x cubed underneath the x cubed, plus 3x squared underneath the minus 3x squared, and minus 5 underneath the plus 5. All the rest of these pieces, I think 5 of them, come down. 3x squared h plus 3xh squared plus h cubed minus 6xh minus 3h squared all over h. Right, I already got these crossing lines through. We'll get 3x squared plus 3xh plus h squared minus 6x plus minus 3h. So the pieces you really want to pay most attention to are the ones that don't have an h left over. So 3x squared minus 6 were those two pieces, and let's see what happens there. The other pieces were still around, but when we put in 0, they disappeared, and we got 3x squared minus 6x equals 0. Well, the factor, they both have a 3x in both these pieces, so let's GCF those out. Take a 3x and 3x out, and we get 1x left. Divide by 3x, we get a minus 2. Set each piece equal to 0. Don't forget the 3x. 3x equals 0, give us x is 0. Set this equal to 0, we get x is 2. And this will have 2 extrema. Why? It is an x cubed. And that wraps up today's lesson. If you have any questions, send me an email. Thank you.